In this video, we will discuss about methods of obtaining the transfer function in the MATLAB. I have written here three methods. One is using the equation. Second method is using the coefficients, and the third method is using zero, pole, and the gain. We will discuss about the first method, that is using the equation. For example, here I have written the transfer function as 20s divided by s square plus 11s plus 18. Okay, this is our equation. In order to write the commands in the MATLAB, what you need to do is you need to define this command TF, that is the transfer function command. So here in the MATLAB editor window, I have saved this program as TPGM, that is transfer function program. This is saved as a .m file. The first command is a CLC that will clear this command window. Yes is the name of the transfer function variable, and you need to use the command TF. And after this one, after this command, you need to write the equation of the transfer function. With that, we have defined it as 20s by s square plus 11s plus 18 that I have written here. So let us execute this. So here I have executed this, and you got the transfer function equation as 20s divided by s square plus 11s plus 18. So this is one of the method to obtain the transfer function. Let us see the second method, that is called as using coefficients. For the using coefficients, what you need to do is you need to find out the coefficients of the transfer function in the numerator as well as the denominator. For that, the command will be in this way. So you need to write the command TF. Okay, in a bracket, what you need to write, numerator coefficients, comma, denominator coefficients, denominator coefficients, denominator coefficients. Okay, bracket complete. Now here for this particular transfer function, if you see the numerator, the coefficients in the numerator are, here there is only one value of s, which is 20s. So we can say that in the numerator there is only one coefficient, that is 20. So numerator coefficient is equal to 20. And in the denominator, there are three values. So denominator coefficients are 1, that is coefficient of s square is 1, coefficient of s is 11, and a constant is 18. So denominator coefficients are 1, 11, and 18. So this command will become TF, okay, in bracket numerator coefficient, that is 20, comma, denominator coefficients are 1, 11, 18. Okay, so let us write this command in the MATLAB. Okay, so here these two lines of the program, I will comment them, so that in the same program I will write using the coefficient. So what we need to write is h is equal to TF, in bracket numerator coefficient is what it is, 20, okay, comma, denominator coefficients are 1, 11, 18. These are the denominator coefficients. Okay, let us execute this one. So here is your transfer function. This is by using the coefficients. Okay, so here let us execute this program in order to get the transfer function. So you can see, okay, here I need to write it as a 20, 0 because I need to get 20s. So let us run this one. Okay, this is our required transfer function 20s by s square plus 11s plus 18. Now let us go for the third method, that is using zero, pole and the gain. Okay, in order to find the zeros of the transfer function, you need to equate the numerator of the transfer function to 0. So what is our numerator is 20s. So if this is equated to 0, s is equal to 0, that is there is one zero that is located at origin, or s is equal to 0. Okay, now you need to find out the pole. For that, denominator of the transfer function will be equated to 0. So let us equate denominator of the transfer function to 0. Okay, so plus 18 is equal to 0. So here you need to find out the roots of this equation. So this will be s square plus 9s, that is 9 2s are 18, 2s 9 plus 2 11 plus 18 is equal to 0. So what are the poles of the transfer function is s is equal to minus 9 and s is equal to minus 2. These are the poles of the transfer function. Now here gain, value of the gain k is equal to 20. Gain is denoted by k. This is the gain of the transfer function. Gain of the transfer function. And in the third method, you need to use the command zpk. That means you need to write first zeros of the transfer function, then you write down the poles of the transfer function, then gain. So what is the format of this command is zpk. In square bracket you need to write the zeros, okay, then comma, you need to write the values of the poles, okay, and then you need to write the value of the gain. Okay, this is the command to get the transfer function in the third method. So let us write the MATLAB command here. Okay, so I will make this as a comment. On the next line, I will write h is equal to zpk. In bracket, what you need to write? First zeros. Okay, zeros. How many zeros are there? There is only one zero. That is 0, comma. Poles are nothing but they are minus 9, comma, minus 2, and the value of the gain is 20. And the value of the gain is 20. Okay, this is the command to get the transfer function. Let us run this one. Okay, so this is your transfer function. If you multiply s plus 9 into s plus 2, you will get denominator of the transfer function, that is s square plus 11s plus 18. So here you can plot the poles and the zeros in the s-plane. For that you use the command pole zero map, okay, and inside the bracket write down the transfer function. Okay, let us plot this one. Okay, I have written the command pole zero map h. Okay, we will run this and see the mapping of poles and zeros. So you can see here this cross mark indicates the pole. Okay, you just if you click here, you can see the value of the pole is minus 9. Okay, here there is one more pole where its value is minus 2, and there is only one zero which is located at the origin. Okay, so these are the three methods to obtain the transfer function in the MATLAB. Thank you.